And since I send the link for the A section students, let them join after 15 minutes. So we'll start with saying, so you have understood how the Schmitt circuits work, right? And so now let us see how the Schmitt circuit can be designed. That is your design of your non-inverting and your inverting Schmitt circuits. So did we see the circuit symbol of the inverting Schmitt trigger? Okay. So now we will see the circuit symbol of the inverting Schmitt trigger. We didn't discuss the hysteresis also? I think we discussed it. Yeah. So now we just need to discuss about the symbol. So circuit symbol of this can be defined by I think almost all are there. Or should we wait some more time for some more time? Okay. Okay. So meanwhile, let me discuss the op-amp. I know you guys have internals and but I also need to teach you guys. Okay. Similar to the inverting Schmitt trigger, non-inverting Schmitt trigger, we have the inverting Schmitt trigger also. And you say it's similar to it. So your circuit's remain like this. Yes. Okay, someone is trying to join. Yeah. Is my window visible? This is your symbol of a inverting Schmitt trigger, or the other way around also it can be written. 1 second. With V in and V out and a bubble at the output. So this is your non-inverting Schmitt trigger representation with a inversion at the end. Is that fine? Any doubts? So I think almost all are there. No. Okay, just confirm whether there will be joining or not, Sanjay. Because if they are not coming, let us at least continue it without wasting time for them. Yeah, I think I have uploaded the notes till integrators, right? Now up to different active filters. Okay, integrators and Schmitt triggers, I'll be uploading it now. Okay. Done. So meanwhile you guys do it, I've also uploaded the file. Next. So we'll see the design part of your inverting Schmitt trigger. So did you have all, I hope you all have understood the working of the Schmitt trigger circuit and how the transfer characteristics produces an hysteresis curve. Is it not? Now? Yeah, thank you. Next, we'll see how an inverting Schmitt trigger circuit is designed. So to see that, the first thing what we need to do is we need to take the op-amp circuit and start analyzing this op-amp Schmitt trigger circuit as any other op-amp circuit. Okay, so I call this node to be V plus. Now, can you analyze this op-amp circuit and tell me what will be the voltage and how do you analyze it first of all? Applying the KCL at node V plus, what happens? V plus is equal to R1 divided by R1 plus R2 into V out. Did you get this equation? All of you? Yes.
Yes, ma'am.
Now, let us see. So this is my inverting Schmitt circuit. So what happens when Vn is greater than V plus? What happens to the output voltage? What happens to the output voltage when Vn is greater than V plus? Now only we have discussed the working of the Schmitt circuit, which is also your inverting Schmitt trigger. What happens when V is greater than V plus? Come on, guys. The inverting ನಿಮಗೆ ಯಾವ ಸ್ಮಿತ್ ಸರ್ಕ್ಯೂಟ್ ವರ್ಕಿಂಗ್ ಅರ್ಥ ಆಗಿದೆಯಾ? ಅರ್ಥ ಆಗಿದ್ರೆ ಇದು ವಿಷಯ ಹೇಳ್ತಿದ್ದೀರ. ಏನಾಗುತ್ತೆ? ಇನ್ಪುಟ್ ವೋಲ್ಟೇಜ್ ನಮ್ಮ V ಪ್ಲಸ್ ಗಿನ ಜಾಸ್ತಿ ಆಗದ V out ಏನು? Yes, the out will be Vn. Okay. Similarly, if Vn is less than V plus, then V out is equal to Vh. So the transition of the kalvam. Now let us consider initially my output, initially V out is equal to VH. Initially V out is equal to VH. What happens when V out is equal to VH? So now VO is nothing but your V out. Initially, V out is equal to VH, and let us consider V plus to be equal to V1 when output is equal to VH. Okay, when output is equal to VH, we assume the output. We get the output voltage to be equal to VH. So if I assume that, so V1 is equal to R1 divided by R1 plus R2 into V out. When V1 is equal to R1 divided by R1 plus R2 into V out. So what is V out here? It is VH. So I'll also replace it with VH. So can I say now, this is the voltage at which your output is changing to VH. You all agree? V1 is the voltage where your output changes from low to high. So when your output changes from low to high, so we're at input V1. So I can call this V1 input also as my upper threshold voltage. that is your VUT. So VUT will also be is equal to R1 divided by R1 plus R2 into VH, and I call this to be equation. Similarly, what happens when, now let us take the other condition when Vn is greater than V1. So what will be the condition of V out? It will be at a lower potential. When it is at lower potential, say let us assume the input voltage is V2, or I can say the voltage at the non-inverting terminal is V2. So I can say now V2 is equal to V plus. So what would be V2? V2 is equal to R1 into R1 plus R2 into VL, because my output voltage is equal to V2. So whenever my input voltage is lesser than V2, the output remains, output is in VH. Thus, whenever my input voltage goes lesser than V2, the output is at VH. So thus, we can say that V2 is your lower threshold voltage. And I say V2 is the lower threshold voltage. So what you guys need to do is now, so if you try to simplify it now, V1 is my upper threshold voltage and V2 is your lower threshold voltage, which is given by R1 by R1 plus R2 into VL and VH respectively. So is it clear till here? How we obtain the expression for the upper threshold voltage and the lower threshold voltage. So now what is your hysteresis voltage? That is nothing but the difference between these upper threshold and the lower threshold voltage, that is your VUT minus VLT. Okay, I call this to be equation 4. Yes. Okay. Okay, I'll just do it again. At least you understood what I told, right? Yeah. Okay then. Just verify it with whatever I have discussed. Okay? Thank you, Sanjay. I was unaware of it. Now is it fine? So now we have seen that how the inverting Schmitt triggers can be designed. Now, as we said, for the ideal case, when the upper threshold VH and VL are equal and opposite in direction, I would get a symmetric circuit. When I say I would get a symmetric circuit, so what will happen when you get a symmetric circuit? The symmetric circuit can be what? How can I shift this symmetric circuit? How can I shift this symmetric circuit? By providing a reference voltage. By providing a reference voltage, I can shift this symmetric circuit, or I can say the hysteresis loop, which is symmetric around both x and y axis. So something like this. So I get a symmetric circuit here. So by providing an additional reference voltage, this symmetric hysteresis loop can be shifted towards right or left. Okay? Any doubts? Now I give you guys an important task. So this is my circuit with This is your op-amp circuit with reference voltage. So we have discussed without the reference voltage for the same inverting Schmitt trigger, is it not? See where your R1 was grounded, it is connected to a DC potential. Now try to analyze this circuit and find out the expression for VUT, VLT and VREF. Sometimes we also call your VUT and VLT as VUTP and VLTP because that is nothing but your upper triggering point and the lower triggering point. Okay, is that clear? Okay. Sudhir is there?
Yes, ma'am.
Sudhir, in case the students go beyond 100, can you add it? Create a meeting and add them.
Okay, ma'am. We'll take care of it.
Okay, thank you. Okay, so now I assume I'm just repeating it for the other students who joined now also. See, we have given a reference voltage at R1 instead of connecting it to ground. What happens when you give a reference voltage at R1 instead of connecting it to ground is you connect it to a ground and now I'm giving a reference voltage. What is the significance of this reference voltage? As I told you already, it shifts your hysteresis curve from the VH and VNR equal and opposite amplitude. So now find out the expression for VUTP, VLTP and V reference for this op-amp circuit by analyzing the op-amp circuit as we did for the previous case. Martiram, shall I leave this as an exercise for you guys? Okay, I'll just give you some 10 minutes time so that you can try it out. Okay? Note down the circuit. Done? It's a very simple op-amp circuit, is it not? Once you understand the hysteresis curve, it's easier. Got it? Done? Okay. So along with V plus, now find out what is VLTP and VUTP. So now, what will be your V out? Same way as we analyzed for the previous case. What will be the V out when input voltage is greater than V in, and when it is less than V in or V plus? Okay. So here I'm trying to make, now I'll give you one more hint. Instead of taking it in our lower VH and VL, sometimes what we do when we are trying to design a circuit, we take VH to be plus VSAT and VL to be minus VSAT. VH to be plus VSAT and VL to be minus VSAT. Okay, VL VH ಅಂತರದ represent ಮಾಡಬಹುದು, V plus VSAT and minus VSAT ಆಗಾದ್ರೂ represent ಮಾಡಬಹುದು. So So just check this. But do you get the expression? Okay, sorry. You get the expression like this for VUTP and VNTP. Instead of VH and VL, it is taken as plus VSAT and minus VSAT for your convenience. For the convenience, we have taken it as plus VSAT and minus VSAT. Yes, did you guys get it? Same expressions you have got, everyone? Please reply. Yeah, all of you got the expression for it? Yes. So now let us see how the non-inverting Schmitt trigger can be designed without a reference voltage. So with reference voltage, you have understood now. Just you will have an additional term. What is the expression for Vref? So now I'll ask you one more question. Given VUTP and VLTP, okay, can you design a Schmitt trigger circuit? With VUTP and VLTP, can you design your Schmitt trigger circuit? Given VUTP, VLTP, can you do it? Yes, based on the certain conditions when you apply the voltages, you will arrive at the conditions for R1 and R2, and based on that, you can choose R1 and R2. If we take plus VH and VL as VSAT, you know what will be your VSAT voltage? 90% of VCC. Alright? VSAT is 90% of your VCC, and then when you get 90% of VCC, you can assume and find out the values for the So if you observe here, I'll just show you an sample copy. Okay. So where we take the output voltage to be at plus or minus 6 volts. So if I find out what is VH, so now you know what is VUTP and VLTP, what is V saturation. So knowing VSAT, VUTP and VLTP, can you get the relationship between R1 and R2? Once you get the relationship between R1 and R2, assume any one and find the other. Is it not simple, guys? Yes. Once you know how the Schmitt trigger circuit works and the basic expressions, you can solve the problem. Okay? I hope you guys are all clear with whatever is being discussed now. Shall we proceed with the design of a non-inverting Schmitt trigger circuit? Okay, thank you. So now how does a non-inverting Schmitt trigger works? It is the vice versa of your inverting Schmitt trigger. That is when Vin is greater than the lower threshold voltage, your output is, sorry, when Vin is greater than upper threshold voltage, your output is at VH, and when Vin is less than that, it is at VN. So in general, I can say now, so I'll just remove it. If see, once you understand this, you can design any circuit, see, as you did it for your reference voltages. If V plus is greater than 0, what happens when V plus is greater than 0? What will be the output voltage for an non-inverting Schmitt trigger circuit, sorry, then the output voltage would be VH. That is when it is beyond your upper threshold voltage, your output would be high. And when it's below the lower threshold voltage, or when it's equal to lower threshold voltage, then it is equal to low. That is then V out is equal to VL. So now I'm trying to make this point very clear, pretty clear for you guys. So once you know that once you understand the transfer characteristic, designing the circuit will not be much difficult. Now, similar to the previous case, apply KCL at the node V plus. And tell me what is the expression for V plus in terms of V in and V out. So if you observe here, V plus minus V in by R1 plus V plus minus V out into, divided by R2 is equal to 0. So rearrange the input and the output terms to one side and V plus to the other side. So I get, after simplifying it further, I get V plus is equal to R2 into V in divided by R1 plus R2 plus R1 into V out divided by R1 plus R2. Any doubts? So with this, so let us analyze it as we did for the inverting Schmitt trigger. When the output voltage is at VL, so if my V out is equal to VL, so let us take my input voltage is at V1. Okay, so when my input voltage is at V1, so let V plus is equal to V1, then I get V1 at R2 into Vn divided by R1 plus R2 plus VL R1 into, what is my input? Output voltage VL divided by R1 plus R2. Is that clear? So as per our condition now, what happens when V1 is greater than 0? V out is equal to V out is equal to VH. When V out is equal to VH, so what should happen to this equation? So when V1 is greater than 0. So when I say it's V1 is greater than 0, can I try to bring this term to the other side? When V1 is greater than 0, we said we get V out is greater than, V out is equal to VH. So if I assume this to be here, so can I bring any one of the terms to the other side? So now can I say R2 into Vn divided by R1 plus R2 is greater than minus of VL into R1 divided by R1 plus R2. Can we do that by taking V1 to be a 0, but that is it is greater than 0. So I'm putting one term to the other side and V1 is greater than 0. So that means this, that means this whole term goes greater than 0. When this whole term is greater than 0, I get R2 V in by R1 plus R2 plus R1 V out by R1 plus R2 is greater than 0. So you bring the other one to the other side, that is your V out. So I get R2 V in is greater than R1 plus R2, which is greater than minus VL by R1 plus R2. So if you observe here, these two gets cancelled out. So I get V in must be greater than minus of V1 into R1 by R2, or I can say the other way around, R1 of R2 by into minus of VL. Yes? Correct? What happens in this case when Vn is greater than minus of R1 by R2 into VL? Well, here I get the output changes. The output changes to VH whenever Vn is greater than minus R1 by R2 into VL. Is it not? So when I say the output changes to VH, when Vn is greater than minus R1 by R2 into VH, can I call this Vn as now VUTP? That's the output triggering point. V. Yes. ಹೇಳ್ಬೋದಾ? VUT is equal to minus of R1 by R2 into VL. So let me call this equation to be equation 2. Similarly, can you do it for the other case? Now where V1 is, or I can say where V plus is equal to V2. When V plus is equal to V2, what will be V out? V out is equal to VH. So for simplicity, we take VH and VL to be plus VSAT and minus VSAT respectively in our experiments. Is it done? So now what happens again when you simplify it? I get V2 to be, now this would be an expression for it. So V2 to be R2 into B in R2 into B in divided by R1 plus R2 plus R1, what is V out? VH divided by R1 plus R2. So now let us consider the same condition then. V1 is less than 0. Here we are getting VUT is a negative value, but since my VL, if my VL is a negative value, VUT will be a positive value. So you need not worry about thinking that I'm getting a negative sign in my upper triggering point. Now what happens when V1 is less than 0? What will be the output voltage? The output will be equal to VL. So now let us take, when V2 is less than 0, I'm sorry for this. V2 is less than 0, so I get the output voltage to be VL. So now when you simplify it further in the similar manner, I can say R2 into V in, this would be VH. R2 into V in by R1 plus R2 is, instead of greater than, it is lesser than minus of VH into R1 by R1 plus R2. And similarly, these two terms cancels out. So I get the expression for V into V lesser than minus R1 by R2 into VH. Is that clear? So whenever your input voltage is less than minus R1 by R2 into VH, you get the output voltage to be low. So when you get the output voltage to be low, whenever your input voltage is lesser than minus R1 by R2 into VH, can I call this potential, that's your minus R1 by R2 into VH, to be a lower threshold? Yes? So now we got our lower threshold voltage VLT is equal to minus of R1 by R2 into VH. VLT is equal to minus of R1 by R2 into VH. Has any doubts with designing this? So I call this to be equation 3. So now we have understood how the expressions are derived for your inverting and non-inverting Schmitt-Trigger circuit, and this would be a hysteresis curve for your non-inverting Schmitt-Trigger with VH and VL equal and opposite in polarity. So in most of the cases, what we do is we take VH and VL to be VSAT plus VSAT and minus VSAT. Clear with this? Now, similar to this, here, instead of Vref, instead of ground here, take this voltage to be VR. And can you find out the expression for VUTP and VLTP as you did for the inverting Schmitt-Trigger? Matiran. No doubts? Yes, guys? Did you guys understand? Or am I too fast? Yes, you will try. Okay, I think I didn't see your message. Sudhir. So any doubts, guys, with this? So this is with your design of your op-amp circuit or a Schmitt-Trigger circuit. So this Schmitt-Trigger circuit, for this Schmitt-Trigger circuit, I need not give only sine wave input. I can also give a triangular wave or any wave input, so that based on this UTP and ULTP, your output will be, you get a square wave with a different duty cycle. So when you say you're getting a square wave, so if you observe, any waveform is converted into a square wave through your Schmitt-Trigger, is it not? So we call these, we use this Schmitt-Trigger circuits and also your wave shaping circuits. Your Schmitt-Trigger circuits are also used as your wave shaping circuits. Any doubts with this? So with this, I've also covered the theoretical concepts of your Schmitt-Trigger, and I hope you can, the guys can design your Schmitt-Trigger circuits. Yes? So with this, shall Go through the manual. Yeah, thank you. Now, so this is your Schmitt circuit. I'll send the other one. This is the older version of it. Okay. So what are the components required and given any specification? So here you see the specification is 4 volts and 1 volts. VUTP should be 4 volts and VLTP should be 1 volts for an inverting Schmitt trigger. So with this, we said that VH and VL is plus or minus VSAT. So if you observe here, VL is at minus VSAT, so we have got a negative sign here. Whereas in our derivation, it was all plus VL and plus VH. Alva, observe Madidradna. So what is your VH? It's VUTP minus VLTP. So I get 2 times the VSAT into R1 by R1 plus R2. So based on this, you can choose any one of the resistance and find out the other. Now I'll give you an important task. Can you tell me what is the role of these Zener diodes? In the circuit? What is the role of the Zener diodes in the circuit over here?
Voltage regulator.
Voltage regulator. It is used to limit the voltage based on what is R and D naught. Okay? Is it clear? So now I will leave this part of design to you to conduct and tell me what will be V naught and V dash. Is that fine? Yes or no? Using this, you have to tell me you have to design the value for this resistance R. So go through these voltage regulator circuit with the Zener diodes connected back to that and tell me how you obtain this resistance value. So I'll just give you a hint over here. See, this Zener resistance is depending on VSAT minus of VZ plus V gamma, where IZ is your current through the Zener diode. Okay? So I want you guys to just go through the design of this and obtain the resistance value. Okay. So based on this, if your Zener diode is a 5 volt Zener diode, so all your output voltage will be limited to plus or minus 5 volts. Is it not? Even though you have designed it for a V saturation, right? Well, saturation ಗೆ design ಮಾಡಿದ್ರಲ್ಲ saturation voltage ಗೆ because of these Zener circuit whichever you are connected here to limit the peak value, whatever the peak value you are limiting it depends upon this Zener diode. Okay, so if I ask you to limit your amplitude to Zener voltage of 5 volts, so based on that you need to find out what is the resistance required between VO dash and VO. Okay. Yes. Can you guys do it? Yeah. And then these are your expected graphs we have already discussed. Similarly, your design procedure, you have given VUTP, VLTP, the output voltage there I have specified to be plus or minus 6 volts. But here we say in your lab manual in the newer version, I say your output voltage should be plus or minus 5 volts. So based on that, you're going to choose the R value suitably. That I'm leaving it to you as an exercise. Will you guys do it? I want you guys to be pretty confident and say yes. So I am giving you only, I have left out with that value for you to find it. So is it difficult now? See, wherever you have plus VSAT, it is VH and minus VSAT is your VN. Okay? So the designing of the circuit is not a problem. And choose V0 to be, if I say V0 should be plus or minus 6 volt, and this design for V0 dash. So based on this, you find out the resistance R based on the saturation voltage of your Schmitt trigger, and these are expected graphs. And so I'm giving here your up amp ZCD we are checking, and then we are applying the sinusoidal input of 1 kilohertz and peak value Vm. So this will give you the output on the CRO, and now put it in XY mode and obtain the hysteresis graph and obtain what is the hysteresis voltage, and you do the same thing for your inverted circuit. Okay. So what are things you need to note it down? Here, along with this, you also need to note down VO and VO dash. You also need to note down VO and VO dash for both inverting and non-inverting circuit. Okay? I have to do with the design part of the problems, but I'm not going to do it now because I know you guys are not interns. Okay? So with this, in the manual, I've also provided space for obtaining the transfer characteristics by giving a certain reference voltage and without giving, yes, Arshit, it's the voltage regulator. You're right. So now with this, we have also asked you to design an output waveform and a transfer characteristic for a Schmitt trigger circuit when VR is 0, when VR is not equal to 0, both for inverting and non-inverting, for a sinusoidal wave, and then for inverting and a non-inverting for a triangular waveform. Martirashtana, next week lab ಅಲ್ಲಿ. Along with that, what is it you guys need to show? Event synopsis. Event to synopsis. Yes. And then also you
For the lab faculty, we have to show, ma'am.
Yeah.
Okay.
Event to lab ಗೆ ಸಂಬಂಧಪಟ್ಟಿದ್ದಲ್ಲ SLE component ಆ lab ಅಲ್ಲಿ ತೋರಿಸಿ.
Okay.
Okay. And then that's it with whatever we have discussed for this week lab. So, and also you guys need to keep your reports ready. Now I think you guys are all clear with what has to be done. I know most of you are playing. Say some of them have not done and they say, ma'am, we have done with the soft copy and all. But don't do that. Whatever we are doing is for your good. Okay? Anything else we need to discuss? ಇನ್ನೇನಾದ್ರೂ ಡೌಟ್ಸ್ ಇತ್ತಪ್ಪ?
No, ma'am.
Ma'am, if that grouping word file is there, can you
You
share
haven't
it?
received it, Sudhir.
Like
Okay.
few students have asked me, so I think like you told
Okay
them
then.
finalize and you'll share, no ma'am.
Yeah. I think I shared that. Sanjay, did I share it to you? Okay, then just be online. I'll send it to WhatsApp right now. Because it's already high time. When I said, yeah, ma'am, it is there, few students told me. So I said, okay, I felt okay, they have, and then I ignored. So, oops. For A section, it is there. I think these students don't have any issue, right? Because you're already 9 members in each. Right. Okay. SLE component groups I have, I think. 1 second. Yeah, both A1 and both A section and B section is there. I'll share it. So that you guys won't have any confusion again. Telling ma'am, you didn't tell us. So just check your message. Meanwhile, I'm also sending it to Sanjay. Sanjay banta nodappa. Yes, Sudhir, now I think it's clear for all.
Ma'am, excuse me.
Yeah, Pradyumna.
Ma'am, ಈ ಸತಿ ಲೈಕ್ ಇಂಟರ್ನಲ್ಸ್ ಇದೆಯಲ್ಲ ಮ್ಯಾಮ್
ಹಾ.
ಪ್ರತಿ ಸತಿ ನಾನು ಔಟ್ಸೈಡ್ ಹೋಗಿ ಬರೀತಿದ್ದೆ. ಬಟ್ ಈ ಟೈಮ್ ಲಾಕ್ಡೌನ್ ಮತ್ತೆ ಈ ತರ ಇಲ್ಲಿ ಸೈಕ್ಲೋನ್ ಎಫೆಕ್ಟ್ ತುಂಬಾ ಜಾಸ್ತಿ ಆಗಿದೆ.
ಮತ್ತೆ ಏನ್ ಮಾಡ್ತೀಯಾ?
ಅದಕ್ಕೆ ಮ್ಯಾಮ್ ಲೈಕ್ ಈಗ ಅಂದ್ರೆ ಮನೇಲಿ ಬರೀಬಹುದು, ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಬಟ್ ಈ ಗುಡುಗು ಸಿಡ್ಲೆಲ್ಲ ಬಂದ್ಬಿಟ್ರೆ ಅಂದ್ರೆ ಮಳೆ ಇಲ್ಲ, ಸೊ ಜೋರ್ ಬರುತ್ತೆ ಇಲ್ಲಿ ಅಂದ್ರೆ ಕರೆಂಟ್ ತೆಗ್ಬಿಡ್ತಾರೆ, ಅದೇ ಪ್ರಾಬ್ಲಮ್ ಆಗೋದು.
ನೀನ್ ಒಂದ್ ಕೆಲಸ ಮಾಡು, ಲ್ಯಾಪ್ಟಾಪ್ ಅಲ್ಲಿ ಬ್ಯಾಕಪ್ ಇಟ್ಕೋ.
ಅಂದ್ರೆ ಲೈಕ್
ಬ್ಯಾಟ್ರಿ ಚಾರ್ಜ್ ಮಾಡಿ ಇಟ್ಕೋ. ಇಂಟರ್ನಲ್ಸ್ ಇದೆ ಅಂದಾಗ ಅಟ್ಲೀಸ್ಟ್ ನಿಂಗೆ 1-2 ಅವರ್ ಆದ್ರೂ ಕರೆಂಟ್ ಇರುತ್ತಲ್ವಾ, ಪೂರ್ತಿ ತೆಗೆದ್ರು.
ಚಾರ್ಜ್ ಪ್ರಾಬ್ಲಮ್ ಆಗಲ್ಲ, ನೆಟ್ವರ್ಕ್ ಇಂದ ಪ್ರಾಬ್ಲಮ್ ಆಗುತ್ತೆ. ಅಂದ್ರೆ ಲೈಕ್ ನಾವು ಬ್ರಾಡ್ ಬ್ಯಾಂಡ್ ಮಾತ್ರ ಬರೋದು, ಲೈಕ್ ನೆಟ್ವರ್ಕ್ ಸಿಗಲ್ಲ ಇಲ್ಲಿ.
ಬ್ರಾಡ್ ಬ್ಯಾಂಡ್ ನೆಟ್ವರ್ಕ್ ಸಿಗಲ್ವಾ ಮಾಡೋದಾದ್ರೆ?
ಅಂದ್ರೆ ಈ ಕರೆಂಟ್ ತೆಗ್ಬಿಟ್ರೆ ಹೋಗುತ್ತೆ ಮ್ಯಾಮ್.
UPS ಇಲ್ಲ ಅಲ್ವಾ?
ಹಾ ಹೌದು ಮ್ಯಾಮ್, ಅದಕ್ಕೆ ಪ್ರಾಬ್ಲಮ್.